Hello, Year 7s. In this video, we are going to be looking at equivalent equations. Sometimes, two equations essentially express the same thing. For example, the equations x plus 5 equals 14, and x plus 6 equals 15, and x plus 7 equals 16 are all made true by the same value of x. Remember, a true equation means that the left-hand side has the same value as the right-hand side. And each time, you can see that we added 1 to both sides of the equation. Sometimes it's helpful to pretend that true equations are a set of scales with different objects that have the same weight. For instance, to say that 3 plus 5 equals 8 means that a 3 kilogram block added to a 5 kilogram block weighs the same as an 8 kilogram block. Let's try an example. So our initial equation is x plus 5 equals 14. Now remember that the value of the pronumeral x does not change, and I'm sure you've already worked out that the value of this pronumeral x is 9. I'll keep that in mind. Now what happens if I add 1 to both sides? I have to add 1 to both sides, otherwise my equation will not be balanced. What do you get now? Yes, we get x plus 6 equals 15. Quickly check. Is the value of x still 9? Yes. Let's try it again. But this time, let's subtract 3 from both sides. What do you get now? Has the value of x changed? Nope, it's still 9, and we get x plus 2 equals 11. Now what happens if we double both sides? What do you think we're going to get? Yes, we get 2x plus 10 equals 28. And by now you can see that if x is 9, our equation still remains true. So what can we conclude? An equation will always remain true if we do the same thing to both sides. The exception to this rule is if we divide both sides by 0, and this is because we know that nothing can be divided by 0. Okay, are you ready to try a few examples? Okay, for this equation, I want to find the result of applying the given operation to the sides and then simplify. So our equation is 2 plus x equals 5, and I want you to add 4 to both sides. What do you think we're going to get? So if we add 4 to both sides, we get x plus 6 equals 9. And we can say that 2 plus x equals 5 and x plus 6 equals 9 are equivalent equations. Let's try another one. 3q plus 6 equals 21, and I want you to subtract 6 from both sides. What do we get? Well, when we subtract 6 from the left-hand side, we get 3q, and when we subtract 6 from the right-hand side, we get 15. So again, 3q equals 15 is equivalent to 3q plus 6 equals 21. Now let's see if you can figure out what operation was used. So here are two equations. 2x plus 10 equals 15, and 2x equals 5. Can you figure out what I did to get from the first equation to the second equation by ensuring that these are equivalent equations? Well, let's see. What did I do to the left-hand side? Well, I subtracted 10. So 2x plus 10 minus 10 gives us 2x. What about the right-hand side? Did I subtract by 10? Yes, well 15 minus 10 is 5. So the operation I used was I subtracted 10 from both sides. Let's try one last example. What operation was used in these two equations? Well, 10 brackets t plus 3, remember we read that as 10 times t plus 3 equals 20, and t plus 3 equals 2. So what did I do to both? Do you think I subtracted by 10? Well, that wouldn't work for the right-hand side. What do you think? Oh, you're too clever. You worked out that it's divide by 10 on both sides. The left-hand side, the 10 disappears, and the right-hand side, 20 divided by 10, it gives us 2. So let's quickly summarize what we know so far. Two equations are considered to be equivalent if you can get from one to the other by repeatedly adding a number to both sides, subtracting a number from both sides, multiplying both sides by a number, and dividing both sides by a number other than 0.